So far in Unit 5, we have spent our time simplifying trig expressions, which means we haven't really been looking for a final numerical answer or a final value for x, but rather we've been simplifying expressions just to write them in a different way than how they started. So the second part of Unit 5 is going to involve solving trig equations. So again, we're solving equations as opposed to simplifying expressions. There's a very big difference. But our strategies are going to be pretty similar, combining our algebra knowledge with our trig identity sheet. So take out that identity sheet if you don't have it next to you yet. Some good rules of thumb when you are trying to solve trig equations is to isolate a trig function on one side, just like you would isolate the variable that you are solving for. Use algebra to simplify your equations, and use trig identities to convert to one type of trig function. You want to have everything in terms of sine, or everything in terms of cosine, or tangent, whatever it might be, instead of having a variety of trig functions all in one problem. So, as a warm-up, hopefully you remember how to solve 2x plus 1 is equal to 0. We're going to say that means 2x equals negative 1. X would be equal to negative 1/2. You get a final numerical answer. So, applying that to trigonometry, we're going to be looking between 0 and 2 pi. So, once around the unit circle. Notice we're measuring in 2 pi, so all of our answers will come out in radians. I want to solve 2 sine of x plus 1 is equal to 0. So, I'm going to start just like I did with solving the algebra. Divide by 2. These types of questions you have seen before on tests, quizzes, practice problems, all of those things. This is asking for an angle x such that the y value is equal to negative 1/2. Well, if you think about your unit circle, sine is negative down in this part. Sine is negative 1/2 at these angles over here. So your answers are going to be 7 pi over 6. And 11 pi over 6. And you're done. Another way to consider doing this, if you have a calculator nearby, is to undo sine. We want to take the sine inverse. So I would take the sine inverse over here. Oh no, I'm going to have some pen issues again. Let's see if I can get rid of those. Okay, take a sine inverse if you need to, and then think about reference angles. But realistically, all of the ones that we are going to solve are going to fall on your unit circle, so having your plate next to you is actually going to be more beneficial than having a calculator next to you. And for Mr. Rump's students who did not get to participate in the craft making of a unit circle plate, you will have to have your identity sheet next to you and use the unit circle that's provided there. Again, using what we know from algebra, I'm going to go ahead and solve for x in our warm-up. When you take a square root, you get plus or minus. Well, this is going to be x is plus or minus the square root of 1 over the square root of 3. Hopefully you all agree that the square root of 1 is 1. We can leave the root 3 there. Then I need to rationalize. So square root of 3 over square root of 3. Final answer. Okay, that should be an algebra review for you. Now, I'm looking between 0 and 2 pi, so again in radians and once around my circle, to figure out 3 cotangent square root of x minus 1 is equal to 0. So I'm going to apply what I did over here. Take a square root. I get plus or minus the square root of 1/3. Well, we already know from our warm-up that that means cotangent of x is equal to plus or minus root 3 over 3. So I'm looking for some angle that has a x over y value equal to positive root 3 over 3 and negative root 3 over 3. If you use what you know from your unit circle, and you take an x over a y, your root 3 over 3's are going to happen up here, and down here, and down here. The reason I have 4 angles this time is because I'm talking about plus and minus. So I'm going to say x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. If you're not convinced that it's these ones up here, take the x value on any of them, 1/2, and divide it by the y value, root 3 over 2. You'll get 1/2 times 2 over root 3. Those are going to cancel. 1 over rad 3, which as we simplified over here, is equal to root 3 over 3. Okay, but hopefully by now you're starting to recognize tangent values in addition to sine and cosine values around your unit circle. Alright, this one we could do in a very similar way. We could add 1 to both sides, take a square root, x would equal plus or minus 1, and we'd be done. Or we could factor this, x minus 1, x plus 1 equal to 0. 2 things multiplying to 0 means that either this first one has to be 0, or this second one has to be 0. So x would be equal to 1, or x would be equal to negative 1. But notice you get the same answers either way. So on this one, I'm going to choose to add 1 to the other side. Take a square root, plus or minus 1. Alright. Secant then is the reciprocal of cosine. So I'm looking for an angle value in which 1 over my x value is equal to positive 1 or negative 1. Well, here are where my x values deal with 1s. And if I were to flip 1 over 1, I get 1. And flip 1 over negative 1, I get negative 1. So my 2 angles that make this a true statement are going to be 0 and pi. Those are equal to x. So there's one way. I could also do a difference of squares. Factor this, secant of x plus 1, secant of x minus 1 equals 0. That means secant of x equals negative 1, and secant of x equals 1. You'll get the same answers that we got over here. Another option is to recognize secant squared of x minus 1 is the same thing from our identity sheet as tangent squared. So if I replace that, now I'm looking for where tangent, which we know is y over x, where is y over x equal to 0? Where is that happening on our unit circle? Well, y is 0 here and here. So again, I would get my angle values of 0 and pi. I don't care how you get there, just get there, making legal math moves and legal trig substitutions. Alright, this one, 0 to 2 pi. I'm going to say we could do some substitution and change this into 1 minus cosine squared. Or we could change this into 1 minus sine squared. But I'm going to take a little bit of a shortcut because of what I know about my identities. If I divide this side by cosine squared and this side by cosine squared, I'm going to turn into having tangent squared equal to 3. These will cancel. These are equal to tangent. So now, to solve, tangent of x will be plus or minus the square root of 3. Thinking about your unit circle, where are my y over x values going to simplify to plus or minus root 3? It's going to happen up here, down here, because I've got that plus and minus. So I need 4 answers. X will be equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, so that's using a trig identity, right? Turning things into tangents in order to deal with them. Again, if you don't believe yourself, take a y value, root 3 over 2, and divide it by an x value. You will in fact get root 3, I promise. The The other way to do this starting problem is to replace sine squared with 1 minus cosine squared is equal to 3 cosine squared. Get things all on one side. I'm going to have 1 equals 4 cosine squared. 1/4 is equal to cosine squared, which means that the square root of 1/4 plus or minus is equal to cosine. Well, the square root of 1/4 is equal to plus or minus 1/2, because the square root of 1 is 1, the square root of 4 is 2. So I'm looking for some angle value that has a cosine of positive 1/2 or a cosine value of negative 1/2. Not surprisingly, it is all of our 60-degree reference triangles, or our pi over 3 angles. I don't care how you get there, just get there. Alright, last one. We've got a mix of sines and cosines and a mix of powers. So I can't do my dividing trick that I did on the last one. I've got this addition over here and I've got this difference of powers. So instead I'm going to say we have to substitute in order to get everything in terms of one trig function. So I'm going to get everything in terms of cosine, because it's going to be pretty quick to replace a sine squared with a 1 minus cosine squared. Distributing in my 2, I'm going to get everything to one side, so I'm going to have negative 2 cosine squared of x minus cosine of x. Subtracting 2 over here is just going to drop to a 0, so this is all equal to 0. Now, I'm going to factor out what I have in common. So both of these things have a negative sign, and they have a cosine, which will leave me with 2 cosine plus 1 equals 0. So again, I took out a cosine and a cosine, and I was left with 2 cosine plus 1. I yanked out that negative also. So now either this has to be equal to 0 or this has to be equal to 0 by our zero product property. Well, this is saying what angle has a cosine value of 0. Cosine is x, so what angle has an x value of 0? That's going to be at pi over 2 and 3 pi over 2. This right here is going to simplify to cosine of x equals negative 1/2. So where is cosine of x equal to negative 1/2? That's going to happen in the second and third quadrant at our multiples of pi over 3. So 2 pi over 3 and 4 pi over 3 are your final answers. Have your unit circle next to you. Again, we're looking for where are our x values 0, so that's going to be up here and down here. And where are our x values negative 1/2, that's going to be at this angle and this angle along our circle. In conclusion, there's a lot of ways to solve. Choose which way you like the best. Alright? If you decide to substitute with a Pythagorean identity instead of dividing to make it into a tangent, like we did on a previous problem, that's fine. Your set of angle answers will come out the same as the way mine come out. Keep in mind that all of your answers are on your unit circle. They are all there somewhere. You've just got to know where you're looking. So keep studying that unit circle. Keep it next to you while you do these problems. Use your identity sheet. Read through the strategies. Look over practice problems. That's all I got for you. Use your algebra. It's going to help you in solving your trig. And don't let this little police officer come after you. Make sure you are always making legal math moves.